pause the recording, rather it just takes away the recording altogether. All right, so I hope you can see my screen now. Right, so let's start. So creating an ERD from investigated facts. We'll identify the entities, we'll identify the relationships, and we'll identify the cardinality and multiplicities, maximum and minimum. And then we will start working on that, that one, the entities. We'll just start working with those. So let's look at that. Super types and subtypes. When you're designing entities, we have something called super types and subtypes. And we basically look at some of these super types and subtypes in a way. We'll just look at that. A subgrouping of entities in an entity type that has attributes distinct from those in subgroupings. It is actually the concept of generalization and specialization, and we'll see that. Supertype, a generic entity type that has a relationship with one or more subtypes. So attribute inheritance, subtype entities inherit values of all attributes of the supertype. An instance of subtype is also an instance of supertype. So this is more of like, the object oriented concept. If you have learned, that is, the concept of inheritance, some concept of specialization and generalization. In entities, that also works. So basic notation for supertype and subtype notation, and you will really understand that one. So relationship in which all instances participate. So supertype is a general entity that will have some subtype of entities. They are called specialized. Now, if I stop here and ask a question, have you guys studied object-oriented programming somehow in the course previously? I think you should have studied that last time. So maybe in a .NET course or somewhere anyhow. So yes, C#, wonderful. Yeah. So that's basically, it's a specialization. It's basically that same form of inheritance or something. So what we say that relationship in which all instances participate, supertype attributes shared by all entities. All the entities, when they shared some attribute, we combine them and we make their one parent. By parent, I mean that one root of that. And then we just define subtype. So relationship in which only specialized versions participate. So basically, these are the specialized relationship that happen over here. Now let's talk about this one. These are the Visio notations. Microsoft Visio has notations, and it represents this one. So it says that relationship, so it is super type, and then this rounded or this line, and then they represent the subtype. Right? So that is specialized one over here, and this is super type. So again, if you go from top to bottom, specialization. When you go from bottom to top, generalization. You guys know that, and you will see that one continued. Look at that here. Employee. All employees have employee number. All employees have employee name. All employees have address and date hiring. Now, these are the common, properties that every employee has. So why not let's make one entity for that particular one? And then there can be an hourly employee that has one extra field called hourly rate. That is a salaried employee that has annual salary or stock option in their entity. Then there is another one, consultant, which has contract number or billing rate over there. So each employee subtype will have its own attributes, its own values. Make sense, everyone? This is basically, as I mentioned, this is more so the same concept that we have discussed in object-oriented programming, generalization and specialization. So you see that hourly employee is a specialization of employee class. Salaried employee is a specialization of employee class. Consultant is a specialization of employee class. Number one. Number two, relationships and subtypes. Relationships at the supertype level indicate that subtypes will participate in the relationship. The instances of subtype may participate in a relationship unique to that subtype. In this situation, relationship is shown at subtype level. Now, what does that mean? Look at that. Here, supertype subtype relationship in a hospital. Patient, outpatient, resident patient. You see, these two are the different entities. And again, Specializations. Every patient will have an ID. Every patient has a name. Every patient will have an admission date, right? And then if you look at that, outpatient, some patients will come and they will just go away. They are the outpatient, check back date. Resident patients are those patients which have the date of discharged. Now, here comes some relationship in other hospital. Responsible physicians. Now, one responsible physician can have many patients or can have zero patients. Maybe there is a physician that does not have any any patient at all, right? So, but if you look at that, multiple, so optional, multiple. But again, if there is a patient, there has to be a physician. That is a mandatory, type that one physician should be there. Both outpatient resident patients are cared for a responsible physician. So both of them will be, cared with that responsible physician. But here comes the resident. For the resident patients, they can have an assigned a bed. And why assigned a bed? Because of course they need a bed because they will be residing in the hospital. So super type relationship again, patients can be, they are cared for. So that's why they are like it's a sibling type of relationship being created over here. Now let's come back here. Generalization is that I was talking about. Generalization, the process of defining a more general entity type from a set of more specialized entity type bottom up. And what is specialization? The process of defining one or more subtypes or supertypes. Again, same concept of generalization and specialization that you might have seen, that you might have experienced before in object-oriented languages and programming. That same goes on with your database modeling. Now here comes the concept. Example of generalization, and you know that these are very vague old examples. Car, vehicle ID, price, engine displacement. So you see that all of them have vehicle ID, all of them have price, all of them have engine displacement, all of them have vehicle name, make and model. Now here comes car has number of passengers, truck has capacity or cab type, motorcycle does not have anything at all. So can we do a special generalization of these? Yes, we can do a generalization. And how can we do that generalization? Look at that. Take all the properties of the common properties. So we just take over here. And why not? We have included motorcycle because it did not have any special feature. So generalized vehicle, price, engine displacement, vehicle name and model. A motorbike was covering that one, right? But a car had number of passengers and a truck has capacity and the capacity type. Is that making mention? So we put the shared attributes in a super type. And again, same generalization and specialization concept. So now here is example of specialization. So part has part number, description, quantity on hand, location, routing number only applied to the manufactured parts. Routing number is when a part is manufactured, it has a routing number. Supplier only applies when supplier has been sent. So can we make specialized classes of that one? Yes, we can make specialized classes. How come? Part, number, description, location, quantity in hand. Now the subtypes, manufactured part, routing number, purchased part has not routing number, rather suppliers. And there is a whole multi-valued attribute was replaced by an associative entity relationship to another entity. Now here is an associative relationship being made because purchased part has supplier ID and supplier ID will have, maybe supplies. It's an associative relationship. And if it supplies something, multiple supplies something, it would be purchased part over here to that one. So this was this was supposed to be a multi-valued one, but that has been changed into what? The associative entity relationship, right? Associative entity. Okay, just move forward. Constraints in super type template. This is very important. And I would like to just, focus on this one because this will be, there will be exam questions related to these subtype. Constraints in super type and completeness constraint. Completeness constraint, whether an instance of a super type must also be a member of at least one subtype. Total specialization rule says yes, double line. Partial specialization rule means no, single line. What does that mean? First of all, remember, it's called completeness constraint. So what is that completeness constraint? Whether an instance of a super type must also be a member of at least one subtype. If it's a total specialization, yes. And there will be a double line around that. If it's a partial specialization rule, no, a single line. How come? Let's see. Patient, if you look at that, this one, the patient. Patient, if you look at that, we have got two lines over here. So what does that two line represents? Look at that, double line, total specialization rule. What does that mean? Patient ID and patient. A patient must be either an outpatient or resident patient. It has to be. When a patient will come, definitely it would be outpatient or a resident patient. Make sense, everyone? So therefore, the relationship when it will be made, we will have two lines between them. These two lines will represent them. Are you guys getting that one? This is very important. Completeness constraint says when there is a total specialization rule, that must be like, every, like, these two which we are specializing must have to be one part of it. It may be this one or that one, but that has to be must part of it. So if it is must, you will represent this one. So a double line represents must relationship or must, must have those, any one of them. Any one of them will be there, mustly. Now let's see an example of single. Vehicle ID, price, engine displacement, vehicle name, and this one. Now look at that. It may be car or it may be truck. A vehicle could be a car and a truck or neither. A vehicle can be neither of them. Remember, the bike was only this one. Madesh, do you remember that the bike did not have any specialized thing over here? So here, if a vehicle is not truck or not a car, still the vehicle can exist. Did you guys understand this constraint, completeness constraint? Total specialization and partial specialization. Everyone, Piyush and everyone, can I have a thumbs up from everyone? You understand? So it's basically when two lines are there, it means we are saying definitely if there's a patient, it has to be a resident or a friend. But if it is a vehicle, it might be a car or truck or neither. So vehicle can exist independently. Right? So that's one thing over here. Let's come. The other part is constraint supertype, disjointness constraint. This is another constraint. Whether an instance of a supertype may simultaneously be a member of two or more subtypes. So whether an instance of a supertype may be simultaneously be a member of two. Can it happen that even though we do the specialization because we want to have all those common properties in one, but is it possible? Disjoint rule says an instance of supertype can only be one of the subtypes. Overlap rule says an instance of supertype could be more than one of the subtypes. That's very interesting. Disjointness constraint. Look at the example. So look at that. A patient, and we have written down D. Disjointness constraint represented by D. Now look at that. This you have to remember that you'll have to just use these terminologies. D. A patient can either be outpatient or resident, but not both. So a patient will be treated or maybe counted as one time as outpatient or resident patient, but not both. So it's a disjoint relationship. Atulya, makes sense that disjoint. If you come over here, this is overlapped. So the part which we are just talking about, this is the part description, right? So a part may be both purchased and manufactured. What does that mean? So a part, for example, you can, sometimes, you do what you need multiple parts, and you can come to the situation where you have that, you have to have multiples. There is an order that is like you get a crazy order. So what you will do, you manufacture the part by yourself as well. But you will say, okay, we can purchase that part as also. Why not? Why not? We can purchase that part. So a company at that same time might have that part manufacturing as well as they will be purchasing the part that as well. So supplier will be involved, the purchase will be done, and this will be called as overlap rule. A part may be manufactured as well as purchased at the same time. Again, you get a crazy order. And you are just trying to mention that one and trying to fulfill that crazy order over there. Make sense, everyone? So that is overlapping part. So it means that these two, both of them can be existing with this part. Like both of them, general specialization might be existing. Third type. So there are discriminators again. Discriminator, subtype discriminator, an attribute of the supertype whose value determines the target subtypes. Disjoint, a simple attribute with alternative values to indicate the possible subtypes. Overlapping, a composite attribute whose subparts pertain to different subparts. Now, what does that mean? It will make much more sense. Look at that. This is very important. So these are called discriminators. So first of all, employee. Look at that. An employee will be either hourly, or it would be salaried, or it would be consultant. One of them. But if you see over here that what we have done, the employee type is one attribute, a simple attribute with a different possible values indicating subtypes. An attribute which will represent different values to make sure that these are different things. So for example, H represents hourly, S represents salary, and C represents the value consultant. Make sense? What is the other type? Let's look at that and then. So look at that. A composite attribute with sub-attributes indicating yes or no to determine whether it is each of subtype. So part type manufactured, question mark purchased, if it is manufactured or purchased. So it might happen that a part type is manufactured, yes, and purchased also, yes. Remember, we have given an example. So a part, maybe you purchase that as well at a crazy order, you are purchasing that as well, or you are just creating that as well. So here, what you will write is that it's a composite attribute which is manufactured and purchased both. So we'll have to mention, is it purchased, manufactured? Yes. It is purchased? Yes. In both situations, we'll say there's subtype discriminator. This is called overlap rule. I hope you guys understand this one. This is overlap rule, right? So let's come back over here. So now example of sub and super type hierarchy. A person, SSN, name, address, gender, date of birth. Overlapping. A person can be, look at that. A person can be employee. A person can be maybe, alumnus, alumni for that one, or a person can be student. So overlapping rule is there. So a person can be employee, a person can be alumnus, and at the same time it can be alumnus and it can be an employee, from the university, from a college, it can be alumnus and it has become employee as well. Are you guys getting that one? An employee and alumnus it can. And sometimes student can be employee as well. If you get a co-op or something in the same college or university, you're overlapping that one. Now, in employee, when you are employed over here, it has a disjoint relationship. First of all, there's a single line. Do you guys remember what does single line mean? There is no double line over here. Who remembers what was the single line? Who will answer single line? What was single line representing? We talked about this before. Does someone remember? I'll have to show you again. Look at that. Where is that line explanation? See here, partial specialization rule. So if, what was that? Whether an instance of supertype must also be a member of that. If it is must, it is double line. If it is not must, it is single line. So look at that. Oh, sorry. Here. So single line represents, you remember, a single line represents that it can be partial disjoint, right? So disjoint, and it's over here, this partial disjoint. So look at that. Faculty or staff. Employee can have a disjoint faculty or a staff. And student, a student can have it is also disjoint. It can be undergrad or graduate student. But there is a double line of, for example. So major, graduate or undergraduate, they can have both have same type of same type of majors. Majors can be same for both of them. So they have the majors of the same, for example. Right. So that is basically typically that one. Okay, so this really ends some of the important examples over here. And now what we'll do, as I have this tendency of always we'll be just doing that. I'm stopping this part over here. And this is, we'll be just using or discussing some of the queries now. We'll write some of the queries of order by. Last time you remember we have written down certain queries. We'll today also write some of the queries, but I'm stopping it over here. And I have to discuss some concept from one of the another slide that is there on our on our course shell. I'll just go with that one first of all, because there are some important concepts there I would like to discuss. So let me just show you, just give me a second. Okay, so what I'll do is that I'll just show you. I'll come back to the slides, right? Content and week 3. DB design. There is another very important aspect of this design, and I would be discussing this slide. You remember I've just done that before as well. That we'll be using that one. So that's also database design in a little different way. And I would like to just talk about that. Why not I download this one? This. Look at that. So it's a design in a different way. So I'll very quickly go and I'll just stop where I would feel that this is something new. A database is a model of things that exist in the real world. Sometimes these things are called entities, sometimes they are called objects. Mostly, when you are creating entities, they will be called entities. Some of these things are tangible: student, automobiles, warehouse, manufactured goods. Other things are intangible: courses, insurance policies, ebooks, etc. So database is basically a model. The components of a model database must consist of tables. Remember, relationships. Table consists of columns, fields. Table contains of data records, rows. Each record in database has unique identified primary key. Records in the other table can reference other records by mentioning their primary keys, foreign keys. They become foreign keys over here. Requirements of our model: minimization of storage. Because the ability to make references, there is no need to store the same data more than once. For example, person table. So again, you remember, information table you will store once and you will never store it back because you want to just keep that. Proper referencing, there is a need to keep the integrity of the references. Right? Data example: a person has a name, home address, office address. Each address has a separate phone number. And we have got that one. In our minds, all this data is joined together. It is very tempting to design one table which hold all this data, but that is not the case. First rule: separate the data. Look at that. This is the data. And again, we would like to have just, one table having everything over here. But look at that. We'll take out the separate address is separated and person is separated. So there are two different entities described in our table, person and address. We need to separate them. We'll separate them out. So look at that. This is very important. The first rule was, look at that. The first rule is separate the data. The second rule is called atomicity. The data in each table must be atomic. This is very important. I need you to remember that atomicity. The data in each table must be atomic. That is, it cannot be divided further. No field can contain the enumeration of the data. What does that mean? They have not mentioned that, but again, so no data can have anything that is data cannot be further divided. For example, addresses can be further divided. So if you have address, you might want to divide that address as well. So you have to make atomicity in the statement, in the data that makes it atomic. Third rule: relationship. If we have one home address per person and one work address per person, then to connect them, we can put a foreign key to person in the address table or a foreign key to address in the person table. It does not matter. If more than one person works at the same location, but only ever works in one place, then we need to put the foreign key in the person table. So again, we will be putting the person table. We will be having that, foreign key table, foreign key, because foreign key will mention that home address and the work address of that particular person. And I'll show you third rule. What if we have more than one person living at the same address and we have persons living at more than one addresses? There are three approaches to solving this problem. Remember, M:M, many to many problem. Adding multiple addresses IDs into person tables, adding multiple records for each person, each with unique address ID, creating a separate join or linking table to express this relation. This is how we will be just try to solve this problem. And mostly what we use is that we will try to create a separate join table. So look at that. They have just mentioned a UML case diagram. So person first name, last name, person address, and address. This was the address. So we have just created a typically entity. So look at that. With ERD will entity relationship diagram will do. A person, first name, last name, and ID. an address ID and all these addresses, and then person addresses will come over here, so that we have got this, this one as that type. So that would be like, it would have the person's ID as well over here. And then, that address can be mentioned over here. Address ID will come over here, and address ID will be sort of a foreign key over here that would represent that. Makes sense, everyone? Third rule, relationship. How to make a relationship? Look at that, like this. So ID 1, Joe Smith has this person ID of 1 over here, and its address is 1. So address is 1 over here that is coming up. It's the home address. Person ID 1 and its address ID 2. So the 2 is basically the work address for Joe Smith. Make sense? These are again trying to create the relationship between these one. More formally, we model the relationships or associations among the objects in the database. Is the association relationship optional? What is the cardinality of the relationship? One to one, many to many, one to many, many to many. And I've just given you enough examples of all these cardinalities before. In addition, are there any additional attributes or properties that are dependent upon the existence of relationship? Example, a grade is a property of the relationship between a student and a course, or perhaps a section of the course. Now, look at that. Fourth rule, do not repeat. Do not repeat. Look at that. If a database contains certain repeating records, it is possible to combine them into lookup table. Rather than, defining or, just repeating something, why not let's put them in one table and combine them? And we'll see that, we'll see one example. Said another way, ideally, we prefer not to store the same information about an entity or object more than once. Often redundant information leads to inconsistencies. Are you guys getting that one? This is very important point. Redundant information leads to inconsistencies where duplicated copies diverge in value. Like duplicated copies diverge in value. Maintaining duplicated information is not cost free. Greater storage required, greater application. These are all the problems that you might want to face over there. Another example, we have a table student ID, SIN, student number, course ID, course name, and grade. Null values are not allowed over here. The design suffers from insert, update, and delete anomalies that ideally we would like to avoid. Now, this is very important. Here they are starting a very important database concept that we might want to discuss, that we'll discuss separately as well. But just remember one thing. This design suffers from insert, update, and delete anomalies that ideally we would like to avoid. So if we have this student information, a table, we would be facing some of the anomalies, problems. Whenever you hear these anomalies, to delete these anomalies or to complete these anomalies, we'll see the solution separately. First of all, what is the insert? We cannot insert a new student without that student taking at least one course. Similarly, cannot insert a new course without the course having at least one student. You see that student ID and course ID are basically the underlined one. So we cannot insert a new student without that student taking at least one course. So a student cannot be entered if it is not taking course. Atulya, are you getting that one? This is an insert anomaly. Unless a student is inserted in a course, they cannot be inserted in this table. And that's really an insert anomaly that is happening over here. Okay. And in the same way, we cannot have course ID because course ID there has to be a course that way. Update anomaly. If a student change their name, it will be necessary to modify each and every tuple row for that student and modify the name stored in each row. If student changes their name, there will be multiple names of single student because of the course ID. And I'll have to just go and change every tuple of it, every value of it. Next, delete. If we delete the last tuple row for a student taking that particular course, we lose all of our information about that student. So again, these are delete anomaly. Insert, update, and delete anomalies over here. Solution. That's very important. And this solution is leading us towards something very important. Decompose the table student into multiple tables. Just create a table called student, fact about the students. Create a table called course, just facts about the course. Create a table called student course, facts about the relationship of the course, student ID, course ID, and grade. Are you guys getting that one? This is a very interesting example. Now deciding on keys. What is the keys? In DB design, one must differentiate between what is entity, object, and for each entity, what are the candidate keys? Candidate keys are again represented by this primary and secondary. What is an attribute of a specific entity object? What are relationships that involve this entity object? Example is a student. A student is a thing and merits an entity object to represent it. Student, we create a student entity. Possible candidate keys: SIN number, student name, internally generated number. Possible attributes of a student can be name, date of birth, address, email, etc. Now, here comes the concept of normalization. And this is a concept that I would like you to just, very much focus on. There is a concept in databases that we said normalization. When you design a database, you first want to normalize your database in a way that you are able to just remove all those anomalies. So I'm giving a, just give me, if it is given here, no, I'm just giving a statement on this slide. This is 18, like slide means 18 of 32. So on 18 of 32, like again, on this slide, I am just mentioning one statement. To overcome, insert, update, and delete anomalies. To overcome these all things, we do normalization. Again, this is not mentioned over here. And I have told you that I would definitely ask these type of questions in exams that are not maybe given directly. So normalization is specifically what? It's the saving yourself from anomalies. And what anomalies are there? It can be insert anomaly and it can be delete anomaly and something like that. So normalization refers to these normal forms. We represent 1NF, 2NF, 3NF, 4NF. And some of them have different names as well. Benefits of normalization. When to denormalize. Sometimes we would like to. I would like you to just read that from LinkedIn. Learning Relational Database Essential Training. You can always would like to go over there on the point. I'll just show you. Essential Training, right? So this is a very good, interesting course that you may want to just take that. It's up to you. So let's come back on 18. Now, first normal form, 1NF. The value stored at the intersection of each row and column cell must be a scalar value. A table must not contain any repeating columns. This is very important. Every database record must have the same number of columns. In other words, columns cannot be omitted. Omitted values in the columns are represented by null. You cannot omit a column. Rather, if there is no data for that particular column, you can represent that with a null. Right? Each cell must hold a single value. There can be no multi-valued attributes. In addition, every record must have a key, singular or composite. There should be a key over there. If database adheres to these rules, this rule, it is 1NF. Again, a 1NF database will have must have a key ID. Every cell will have only single value, and no cell value is no field has been omitted. If there is no data, I'll write null over there, but field should be there. If all this happens, it's called 1NF. And again, look at that. A table must not contain any repeating columns, a scalar value, and things like that. This is called first NF. So look at that. This is unnormalized student enrollment. The student enrollment data, courses and grades, columns with non-scalar values. Enrollment, student name, school term, courses, grades. J. Smith, winter 22, PROG8080, info 800, 8278. J. Smith, spring 2002 for PROG8090, 75, etc. So you have omitted out something over here. Unnormalized. Now, attempt to fix the problem. Replace columns with non-scalar values. How to track more than one courses? Add new columns, course 3, grade 3, etc. Repeating columns, side effect, repeating columns, but let's do that. Enrollment, student name, school term, and look at that over here. In square, we are taking course 1, grade 1, course 2, grade 2. Make sense, everyone? And now When there are values, values are represented, and when there are no values, null is represented. Make sense? Trying to make it one NF in one NF. Okay. In order to fix the problem, we need to eliminate repeating columns. Repeating columns should also be like, there should be. So enrollment, student name, school term, course, and grade. We just represent that. So student name, term, course, and grade. School term, grade, course, and grade. The segment is called N1NF. New side effect, internal redundancy. That is redundant student name and school term values. But anyhow, don't worry. You see that redundant names are coming. J. Smith, J. Smith, J. Smith, Winter 22, Winter 22 courses and all those. There is a problem, but it has come in one NF because every element is separate and there is no two values for one element. Make sense, everyone? This is the first NF. Now comes the second NF. Every column or field of the record must be related to a key, identifying this record. If the key is composite, no column can be related to only one part of the key, only part of the key. Consider the table with the column student ID, course ID, grade, professor. Grade refers to both parts of the key. Professor only relates to the course. So grade is basically, grade will combine course ID and student ID, but professor is only concerned with the course. Why professor is being mentioned over here? Every non-key column must depend on the entire primary key. That's a very important thing. Look at that. In order to fix the problem, we need to decompose the previous table to this one. Student ID, course ID, grade, course ID, and professor. Are you guys getting that one? Because professor had nothing to do with the grade. So why in the world we were storing them in the table? So just keep them out. This combination of two tables adheres to the 2NF. All non-key elements columns refers to the whole key and not parts. The segment is in 2NF. Now it is in 2NF because now every non-key element, look at that. Every non-key column must depend on the entire primary key. So every non-key, professor is a non-key. It should entirely depend on that one. If professor was mentioned over here, professor was not dependent on student, like, the student ID. It was only dependent on course ID. Right? Okay. Third column, third 3NF, third NF, right? Third normal form. Third normalization rule states that no non-key column of a table can define or be defined by another non-key column of the same table. What does that mean? Employee ID, department ID, location ID. Department and location are obviously connected, but connection between employee and location is not necessarily direct. Employee can work at more than one locations. Why in the world we are combining these three? Look at that. In order to fix that, we need to decompose the previous table. Employee ID, department ID, location ID. This combination of table adheres to 3NF. It is said sometimes that such decomposition brings the whole database to a 3NF. Like again, we have just divided that into this one, and now the whole database has basically come up in our, in 3NF. And that is basically what it is doing. It is just showing that 3NF columns over here. Fourth NF. Now, fourth normal form. A table must not have more than one multi-value dependency where the primary key has one-to-many relationship to a non-key columns. Now, this is very interesting. Keys related to independent qualities of entities with another key must be stored in different tables. Consider the following table normalized using 3NF. Employee ID, skill ID, and language ID. Look at that. So they have been like, look over here. Because skills, database, C#, Java, and languages, English, Russian, Mandarin, Hindi, are independent, the data is required to be stored in two separate tables. Are you guys getting that one? So employee ID with skill ID and employee ID with language ID. Why in the world you are combining them? If performed so, the database appears to be fourth normal form. Designers usually stop at the third normal form because the number of tables can expand drastically in the fourth normal form. Generally speaking, yes, one of the very important point. Generally speaking, third normal form is enough. But yes, they are just mentioning it or just trying to explain that. Benefits of like fourth normal form is basically over here. Benefits of normalization. More tables and database has more clustered indexes that makes data retrieval more efficient. Each table contains information about a single entity and each index has fewer columns, usually one and fewer rows. That makes DML more efficient. You guys understand that one? So every table has fewer indexes, which makes DML more efficient. Data redundancy is minimized, which simplifies maintenance and reduces storage. Right? And it's basically mentioned in Murak's SQL Server 2019 for developers. These are benefits of normalization that have been mentioned in that one, right? Let's move forward. When to denormalize? When a column from a joint table is used to repeatedly in search criteria, if a table is updated infrequently, included columns with right values, when those values are frequently searched in conditions, we will denormalize that one. So for example, look at that. You have got customer ID 5435, 435, order number, and all those things. So what we do is that modify this to first, second, and third normal form. The task is basically, this is a table being given over here, and you have to modify this one to a first, second, and third normal form. This is the task basically for that one. So look at that. Over here, if you look at that over here, this is sample solution. So unnormalized form, customer order, customer ID, and all these are here. One NF, same as UNF, no repeating columns. All cells have scalar values. If another item is added to same order number, a new customer, composite primary key, order number plus item number. Second NF, item number, list price, and item description. So that is item price, looks at list price and item description depends on item number, part of composite PK. Order number, customer ID, customer name, and phone. So order is basically customer is already related to the cost order number. Customer ID, customer name, phone depends on order number. Why not? Why we just put in the second NF. Order item, order number, item number, and quantity extended price. These are all rename customer orders to order item. So the customer orders have been changed to the order items. So this is basically the table is basically has been made in the 3NF form. Third NF form is being, and if you look at that one, so order number and customer ID, no change to item and order item in second NF. This is 3NF solution over here. Is that good, everyone? Can I have a thumbs up from everyone? This is a very interesting slide, and I'm just leaving that slide also over there. But I would just go back to my this practice of database. Let's get some hands dirty, and again we will just try to have some of the queries running, and I will just give you some of the tasks for today. So let's add that. Let's open our SSMS. And you have SQL Server 20. I have 19. Just open that one. Open that up. All right. All of you, please open up your SQL Server Management Studio, and we'll just talk. We'll try to talk about some of the queries that we have seen. We'll talk about by order by, and I think we talked about a little about the order by before as well. But let's talk about some of the order by more. I'm waiting for my SQL Server Management Studio to open up. And by the way, just a quick confirmation, by the time it is opening up, my SQL Server Management Studio is opening up. Did you guys see assignment number 1 and 2 being uploaded there? And needless to mention, assignment 1 is nothing but just a little exercise. That's why I've just opened up. Have you guys, first of all, can you guys give me a feedback that you have seen assignment 1 and 2 being uploaded over there? Can I have a yes or no? Seen that? Okay. So Tina, have you seen that assignment 1 is just renaming thing, backup and renaming thing. Okay, Shubham, just go and check that one. And again, I've just made the so the assignment 1 is nothing, but assignment 2 is just some queries that you have to write. And maybe this will also help you out, and maybe something that we will just discuss, continue on. That's why I've given 10 days. So maybe, the next week's class also might be a little, and I might extend a little bit of the date, if I feel that there is something that had to be discussed or some had to be, used, and I'll just, show that one. Okay, so my SQL Server Management Studio is open now. So I'll just connect that one as you guys have done. It should not take that much time. If it is taking that much time, it means SQL Server is not going to connect for me. It really sometimes create fuss for me, the SQL Server. And I know it's not connecting maybe because it should not take that much time. It should quickly connect. So we have to see the order by. You see, it's not happening. I'll have to maybe close it and start it again. I'm waiting for my, like, that has to start, that will start. Okay, let me connect again. So let's try that now. Looks like now it is connected, hopefully. But even it has taken some more time. Are you guys ready with your yeah, so it's now ready. Yeah, wonderful. Ridhiman, thank you. You're ready with your databases and everything. Very nice. So if I, in the meantime, open last time's like queries that we had last time files, let's see what we did here, last week. This was week 2, part 1. Let's open that. Okay, yeah, so we have talked about select. We have talked about some of the declare, like how to define the variables. We have seen the data types or something. Wonderful. So this was the task, and I hope that you guys tried to do the task. But anyhow, let's start a new file today. And I use the COVID database, or if you remember, we have created a SIS database as well. Why not? Let's use that one. So for today, what we are doing, let's use SIS. I have SIS database, and there are lots of tables there. Why not? Let's use that because that is a lot of tables. Okay, so SIS, and if I open SIS, how many tables are there? Let's see. And let's see the tables. It is just opening up the tables. So we have a table, for example, country. Why not? Let's check the country. Select everything from country. Let's run this one, this query. And by the way, the shortcut is the F5 key. If you just hit F5 key, if there's a single statement, by the way, or you have selected the statement, so it should be just F5. The query is still running. You see that 30 seconds have gone and it's executing the query. So it means that there is something seriously wrong with my. Oh, now it's here. So you see that like there are like a lot of countries. I can just work with that one. Let's work with this one anyhow. No problems. So order by, the order by query. Let's start with this one. Some more SQL queries. Order by query is basically what? Let's see that. The order by keyword is used to sort the results set in ascending or descending order. The order by keyword sorts the records in ascending order. By default, to sort records in descending order, use DESC key, keyword. So we can use the DESC keyword. So for example, I would say, let's check some other table, maybe, country table is not that good. Why not? Let's see from accounts. What is in accounts? Account table. Now you have to select that one if you want to run the query in any. If you hit F5, only that, because if you just run F5, hit F5 by any means, it will be like it will just run all the queries on the page, it will run. But if you select one query and just hit that F5, that it will typically run that particular query, not all the queries. Okay, it's taking so long for that. Oh, wonderful. Only 2 records are there, Dhruviman, and my query is taking life for 1 minute. It has just taken the query. So there's something really seriously wrong with my Okay, so which table is suitable for that? Let's do that. Why not? Course student, maybe province, room, session, software. Let's take any of them. Let me just run that now. Select top 10,000 rows. It will run another query, but let's run that one, no problem. We're just selecting a table, randomly a table over here. And we just want to look what table we'll be just using there. Program fee. Do you see that program fee is good? Like there are some multiple records there, Dhruvan. Wonderful. If I can just, I'll just check that. Looks like my system is running very, very slow. And yeah, can you guys just try that one out? Order by, like for example, if you want to just check something by order by, we want to just what we do is that the record that come out, they are in ascending, like by default they are in ascending order. But if you want to make them descending in the towards the end, you would just write over there let me just see that. Let's see that. Yeah, let me just check that one. Okay. So this is basically now it has come up. So it has come from the campus. So campus is again. Yeah, that's wonderful. So right. So let's say that so that's not. So you are saying program fees. Let's say that program fee. My system is running very slow today. I don't know why, the reason. Okay, so program fees has international tuition. Oh, it's not that, it's also not that. Let's find out, no problem. We can find out something. Employee, yes, that employee, let's check that. Oh yeah, so employee is good. You see, employee has a lot of options over here. So now let's use the employee table, no problems. And this is our query that we started. So first of all, let's run that one, and we see select asterisk from employee. And if I run that one, if I just hit F5, you see that we have got this one. Now, so employee does not have a name or something. That is interesting, but let's see. Oh, employee does not have a name. That is a more interesting thing. We need to have something where there's a name as well. Because we would be like to. Oh, I just leave that software database. I have other databases, and you can just work with any of them. Let me check if I have Northwind. No, I've not installed Northwind as yet. Okay. COVID. How many tables do we have in the COVID? We have that person tables, and then let's see that how many values are there in person table. Let's do that with the persons table, no problem, like COVID-19. And again, I told you, do you guys remember that I told you that if you want to just make so I'll just use that. Use COVID-19. And this use statement does what? It will just select the COVID-19 database table, and we have got the person. So now let's see that. So if you look at that query that we're talking about, order by, the order by is basically just bring up. So select static from customers, order by city. So if I just come here and I say select static from persons, right? Let's first of all just do that. And you remember that. Oh, sorry. You remember that I'll have to just run that one, run that. We have got this one. Now, if I say over here, order by, right? So for example, if I say order by city, look at that. Order by city, if I'm using the right syntax. Oh, order by space. So order by, and why not? And then you can just leave them smaller as that, but let's see. Order by city. Now, if I run this command, let's look at that. What will happen? So it will just take out the cities, and you see that and it is just making the cities as from the, in that particular order. So order by the city. Make sense? So it has just, it is just showing the Kitchener and London and the T. So because it and you can just do that with anything at all. So if I just come here and I say first name, for example, first name, and I run this query only, look at that. The first name is basically being baked. Now, in the same way, if you look at that one, in the same way. Oh, so now if we just come over here and if I say DESC, descending. So first name descending, let's run that one. You look at that, the first name has gone now descending. Order by first name, but in descending form. Make sense, everyone? Now it is just, mentioning over there, and it is just, doing its descending one. So that is basically order by. If you in a query, you want to just, make something which is typically being ordered over there. So you will use this order by query over there. Right? And then let's come about the null values. What are the null values? A field with a null value is a field with no value. If a field in a table is optional, it is possible to insert a new record to update a record without adding a value to this field. Then the field will be saved as null value. So null value field, where ID is null, for example, it's very bad practice. ID should never be null, because we want to just, where ID is null, and it's basically generally ID is never null. But we can just check all those records where there's some record has been coming out as a null, for example. So for example, if I just come here and I would say, if I insert some record into that one, if I insert something into this, look at that. Insert into persons, and I directly give the values, right? Values. And I say for sorry, 4, comma, and John, comma, and I say Smith, comma, and for address, I say, Victoria Road, and then comma, and I say the city as Waterloo, for example. Let's run this command and insert some data into this one. So it has just given the data, and let's now run that one. And you see that the Waterloo record is also added. And of course, it is just bringing up with that, the first name as the descending one. So it is just, going and typically going over there. So why not let's put some more record in it, because, that would really make it a little bit more interesting. Now here, I would say, for example, I want to store null here. Let's run that one. One row affected. If I run that one, so you see that null is over there. Now let's add some more records to this one. And if I say 422, something like it's too much. Let's say 22, and I make it null again, and I make change the name, Alan Smith or something, and the second name is null again. So null values, look at that. It will just show the null values over here. So now we have got the null values. So now what we can do is that we can just, find out, for example, select statics from persons where first name, the first name was going is null. Right? Let's try that one. So look at that. So where first name is null, it is just bringing up those records where the first name is null. So in certain situations, you might need, in particular situations, you will need that some of the data that you want to extract is basically not something that has a null value. So we'll just check that with a null value, and it's a very bad practice, because ID should never be null, or we should not find out the record with the null values. But that is something that we. Okay, then we have delete. The delete statement is used to delete existing records in a table. We will just see the example. Delete from customer last name is equal to any name. So if I just come here and I say delete from persons where, let's see that, where first name is null. Let's do that. Just delete those records which have this particular thing. 2 rows affected. Now if I just run this one, you look at that, my record is gone, which has, so delete actually deletes from the table. Right, and there are too much of those one. Why not I remove, and I say where person ID equals to 1. There are multiple 1 records, right? So why not let's remove them. So if I run this one, F5, and if I just show 4 rows have been affected, you see, and if I run that, I don't have any 1 record. So now I can just add a 1 record over here, and I just don't want to have a null here, and I would like to have Smith here, Alan Smith, Victoria Road, or let's say Queen Road, for example, and let's put the Waterloo, no problems. Look at that. Now we have got 1 row affected, and now if I run that one, I've got this 1 ID over there, and of course, it is just it is just giving that particular because it's in the first name is being just used over there. So if I say, for example, this is let's say Amit, what is something like that, right? Add that one, insert that record, and again another 1 record has been added. So let's say 21. Alan ABC, Amit ABC, whatever, Queen Road, add that one. Look at that. So now if I just go there and run that one, you will look at that. These are all the records are coming up. And again, they're on the descending form. If I say ordered by first name, so ordered by first name means that now first name will be taken over. So this is basically the delete. And we have seen the example of delete. Min and max function. Min function returns returns the smallest value of the selected column. Max returns the largest value of the selected column. And again, if you want to just make that min height from the as the smallest person from the customers, you say that min or and it takes up the mathematical value was what is the minimum value or what is the maximum value of that a particular of the particular record. So it's typically just to stand. So for example, if I just come here, here there is no mathematical one, but we can use the ID for that one. So select min and what I want to say person ID from persons. Right. Let's see if persons. Let's see if just give that min. So it says the minimum ID of the person is that one. And if I say max, for example, you want to find out a max something. So max person ID, what is the max person ID that I have? It is 253. And you can look at that. These are there. 1 and 253 are the maximum and minimum. Right. So minimum, maximum there. So, you can represent that aliasing. I hope I remember, you guys remember we have just done that aliasing as well as for example, max. I'm just calling that. Oh, no, max is a reserve word. It might not accept that one. And if I say max, it will accept that one. It should accept that in a square bracket. So now let's do that. You see that now I've just given the square bracket because max is a reserve word. If I just do the max, it will not. So max is basically coming up over here. So as is an aliasing that we just basically do to have that person. Count. Let's come to the count. The count function returns the number of rows that matches the specified criteria. Now that's very interesting. Now look at that. Look at the example over here and the sum function. They've not given the example. Let's do the example over here. So count. If we just come here and look at that, what we can count. We can count maybe that how many records are there with the city, that particular. So for example, so let's say select count and let's say I'll say city from persons where city equal to, let's say, what will do? Right. So now let's run this query only. Oh, what I no. Let's run this query only. Let's run that one. It says 4. There are 4 cities where this is Waterloo. If I just come here and I say if it is London, how many London are there? London records are there. It says there are 2 London records. Make sense, everyone? So this is counting some particular one. Sum, of course, the numerical sum. I'm not just giving an example of numerical sum. You can always test that one. Average function returns any average values. We have those mathematical values that you can just always check on that one. The mathematical values are there. Like is very important. And I would like to just, talk about this because they are wildcard characters as well. So the like operator is used in where clause to search for a specified pattern in a column. There are 2 wildcards often used in conjunction with like operator. Percent sign represents 0 or more or multiple characters. Again, that same concept of 0 or more. And underscore sign represents 1 single character. Now here is something that I would like to just talk about. So let's say some of the cases where customer name like A and percent. Find any values that starts with A. So let's come back and let's run that one. Select, look at that. I would just, select everything from persons where. So for example, you can say first name like, right? And look at that. Look at the syntax over here. Like and single quotation A%. So look at that. Single quotation A%. Now look at that. So it brings up all of those user IDs where their first name starts with A. Make sense? We can say, for example, with J, if there is some name, I think I've given a John name. Yes, so John David is coming up over here. So whatever. So this percent will represent that how many. So it starts with A. Where a customer name like percent %A means that where it is ending at A. So for example, if I just take this percent here, we might not have any name at all over here. But let's see that. Let's run that one. We don't have anyone. But if I say, for example, I think John is there. That is starting with or ending with that one. So if I run this, oh, why it is not running? If I run this one, this query, look at that. The first name ending at N. So percent before means that starting, like, the letter starting and percent after. Now let's see over here where customer name like OR and OR is coming in any, like, in any position inside that one. So now if I just write another query where first name, like, for example, I say anywhere where N comes. And this is, believe you me, this is a very important query execution. Wherever N is there, for example, if I say wherever L is there, look at that. So Michael has L and maybe some random name as L. It is just bringing up that. If I say F and I want to see that whether F runs, yes, F is there in this name, first name. So it is basically anywhere if F exists. Makes sense. And if I want to have two characters, FA, maybe there is no name with that one, but we can check that there is no name over there. But we have John, so I can say OH, for example. Anywhere OH is there, just select that one, and you see that John will appear over here. Make sense, everyone? This is basically that one. Now, what is that other? Underscore R. That's very interesting. Find any values that have R in the second position. So any name that has the second position character, you can just mark that one. So let's come here and paste it. And if I say, for example, the second character is O, underscore O, and maybe after that percent. So again, I'm talking about that same John record because it's basically starting. Let's look at any other record. If I just can find out, oh, still. And if I just say F, there is no starting with the the ending at the F. Oh, it is the ending. So I could write it over here. Any F, right? So I have this name over here, or if I say any, let's do that. So now we have got this one, and now this has MI, for example. So I would say the first letter is I, and then there is anything else at all. So if I just come over here, and if I just see that there are two, because there were MIS. So it's basically coming up that one. Are you guys getting that one? This is very interesting. Find any value that starts with A and are at least 3 characters in length. A dash dash and percent. Starts with A and at least. So again, 2 dash dash underscore underscore. It means that it looks for 2 records. In the same way, A starts with A and has 1 character after that only. And in the same way, where contact name like A percent O, find a value that starts with A and ends with O. So if starting and ending is mentioned, just like that one. So if I just say it starts with J and ends with N, for example, again, I'm just going to the John example, or let's see M and L. We'll just do that as well. So if it starts with M and ends with L, and let's run that one, and you see that these are all the wild characters. And believe you me, wildcard characters are very important, and I would just asking them. Okay, right. So example, you can just do that all wildcard character, and you can just do that wildcard character matching and wildcard character is action. So these are the actions. The square bracket is there. The cap sign is there, and these are some of the. So I would like you to just practice that some of the wildcard practice on that one, and why not, you can use for today's task. I will just add it to the slides. For today's task, use Northwind for some practice today. So the concept that we have discussed, you have to write now. Today you have to write 10 queries at least using wildcards. And again, the things that we have used: order by, and maybe delete as well by using the Northwind database. You can find Northwind DB backup in your assignment 1 and 2. Do you see that? It's already there. And you have to submit that with the name of practice questions, like, practice week 3. So I'm just opening that assignment over here just for the purpose, because it would be counted as the practice or class for today. So I'm just opening that for you guys first of all, and then I'll open for every every other week. This was week 2 practice, and now so I can only see only 15 people have submitted. So you have to submit that by the end of the day. If there will be some lacking in your some of the grades or something, that might that might play a very important role. Week 3 practice, and again it's ungraded, but its submission is today, and I'll mark it towards the ending time of the class. It's 3:30, around 5 p.m. It would be closed, and please find rather I'll just copy that as well for you here, and let's write that one. So you have to write few queries and submit that. And again, as I said, I might not be looking at them right now, but you will be will submit that, and that would, so before 5 p.m. you have to submit that one. So you can find this assignment 1 and 2, and this is what week 2 practice. And I would be happy to just have that one. Assignment 1 is already submitted by one student. That's wonderful. Anyhow, so you will find that one over there. If you have any questions, you can just ask, or I'll do one more thing over here, that before we go, I would put the content like like this one, and this is customer orders Excel sheet, which is not needed. We have not used that, but yes, we have used this DB design, and I will upload the files. I'll just first of all save this query file and save SQL query 1, and I would call it week 3, and I would say what I called the previous code snippets. Oh no, I want to just save them in our folder. Codes, and yes, so it should be week 3 part 1, or it's only part, so part 1. I'll just call it, and you will find these all things over there. I'll add this one. So these are the assignments that I've just added, and week 3 part 1 code, and also the lecture file for today. Lecture 3 it is called. Oh, it is in use. Yes, it won't do that. I will make sure it is closed. So you'll find everything over here. Oh, Sudhir, I'll talk with you, let's talk with after I end this one. Let's talk about that. So week 3 contents are updated over here, and I will upload this my lecture recording. You will find the recording over here, of course, in your course channel, but I would upload that on YouTube as well. If you want the link, you can always have the link, and I might share that link on that one. So any other than Sudhir, anyone else having any questions, just go and do that assignment, like the practice for today. And as I said, by the end of the day, if you'll be missing something, I might that might help you at that point of time. So I would always recommend you to submit that one. And to the end of the day, there will be submissions, and we can just have a look at those submissions, right? Any questions from anyone? If not, it means we are good to go. And again, I'll talk to you, Sudhir, what is the problem, and I'll talk about, I'm stopping recording now. So all those who are looking at the recording, please note that I will be asking questions from what I have discussed today. And again, those you have attended the class, you know that I will be asking some of the important questions that I have mentioned. And I have just said few statements that were not there in the slide. So please keep them in mind. So now if you have no questions, you can write a no question in the chat window and leave, so that we can talk with those people who are here for some questions. So you can write